This is Scott Vorthman, author of vZome. What I'd like to show you today is how to use symmetry systems in vZome, in particular how to switch between them and why you might want to do that. When you first launch the application, you're using icosahedral symmetry. This is obvious in a number of ways. First, of course, the shape of the vZome ball has icosahedral symmetry. That's what you were looking at in the middle of the screen. The shape of the trackball, as well as the colors of the axes depicted, etc., is actually designed to illustrate icosahedral symmetry. And of course, the directions available for building struts are constrained to be directions in the icosahedral symmetry system. So how would we change all that, and why would we change all that? Let's start with how. The system menu shows two symmetry systems that are supported, icosahedral and octahedral. If I switch to octahedral, all three of these aspects that I've mentioned have changed. The vZome ball is no longer a vZome ball. Now it's some unusual shape that has octahedral symmetry. Similarly, the trackball has no more red axes, no more pentagons, and you can easily convince yourself that what you're looking at has the same symmetries as a cube or an octahedron. And finally, the strut directions are constrained, and in fact the triangle is sort of flipped to the other side. So why would one use octahedral symmetry as opposed to icosahedral symmetry? Well, let's go back to icosahedral symmetry to demonstrate that. Suppose that I want to build a tetrahedron, and I know that it's made of green struts, a regular tetrahedron. So let's try to do that with icosahedral symmetry. So I will try to design a triangle, and what's going on? Why can't I connect that triangle? Am I just being clumsy? Let's line it up better. No, evidently I'm doing something wrong. The fact is that in icosahedral symmetry and in real vZome, there are 5 times too many. There are 5 ways to put a green strut into a pentagonal hole, and that's too many degrees of freedom. That's too much freedom for what we want to do. So the solution is to simply switch to octahedral in order to build the tetrahedron or to use the green struts. So I'm now going to turn on green directions, and you'll find it's actually trivial to make a triangle. The last step is to put the tip on the tetrahedron, and that's easy as well. There are no wrong directions in a sense. The only wrong thing you can do is simply due to the symmetry of tetrahedra, and that is try to build the tip in the wrong direction, which you'll quickly find can't be done. What I'm building here instead is not a tetrahedron, but an octahedron. But that's also easy to build. So that's one reason to use the octahedral system, is just to use it temporarily. You can immediately switch back to icosahedral. The structure you built is the same. It's just drawn differently, essentially. The vertices, the coordinates of all the vertices, the vectors, etc., are all the same. vZome simply interprets them and renders a different shape based on the symmetry system you're using. It'll also color the struts differently depending on how you've matched the symmetry system. For example, if I build in yellow, suppose I want to build a rhombic dodecahedron. I may try to find some yellow directions to use and sort of guess at it. It's not that easy. And in fact, if I switch to octahedral, you'll quickly see that most of my yellow struts have turned purple. Well, this is because they're not actually the right struts if you try to line up with the octahedral system. So let's undo those struts and just stick to yellow and see if we can't build a rhombic dodecahedron more quickly. And sure enough, it's very easy. almost builds itself. And again, that's because we don't have any extra yellow directions in this system. And of course, once again, if I switch back to icosahedral, I still do have yellow directions because the two systems are aligned along some subset of the blue axes and the yellow axes and the green axes. So that's symmetry systems in vZome. There's a lot more to say. In particular, we'll have another video and we'll talk about configuring directions for use in vZome. It is related to symmetry, but that's for another time.